Alright, here we go. So today's lesson is going to be on U-substitution. I want you to go ahead and write in the learning target, which is I can find the integral with U-substitution. Let's take a look at example 1. We're going to be doing examples on the left side of your paper, and then I would want you to do the problems on your own on the right side of the paper. First off, our current techniques, the rule that we have when we take the integral using a power rule, which is x to the n plus 1 divided by n plus 1, does not work with this case. So this does not work in this case because we have a bunch of stuff going on. If I wanted to use the power rule here, I would have to multiply this 3 times using FOIL. Then I would have to distribute the x, which would actually be a lot more work than what it is with using U-substitution. So we do need a different technique, and I'm going to go ahead and show you what that is. U-substitution is basically like using chain rule but with integrals. So in order to do the U-substitution, I have to identify the inside function in this expression. The inside function is usually the function that's inside of parentheses. I identify right here because it's in parentheses. This is going to be my inner function. We're going to call that inner function U. And by the way, here I color-coded this. These colors you'll be understanding in a second. But first, what I'm going to do is I'm going to call this inner function U. I'm going to color code that as blue. Alright, now here's going to be our next step. We're going to be taking the derivative of both sides with respect to x. Next up, on the left side here, this is going to become du dx. This right here with respect to x, this is just going to become 2x, and then this just becomes 0. Alright, so in this step that I'm doing right here, the goal will be after I have identified u, what I'm going to do next is I need to solve for dx in this equation. Because actually what I'm going to be doing is substituting the dx here. So in order to solve for dx, what I have to do first is multiply both sides by dx. Because this dx here is in the denominator position, which is a problem. When I multiply both sides by dx, this and this cancel. This will just move over here. So this is going to be the next step. Alright, so remember our goal. So the next step in this process is that we need to solve for dx right here. So what I'm going to do in order to solve for dx is I'm going to divide both sides by that 2x because that's in the way and we need dx by itself. There we go. Now dx is solved for. So dx is equal to du divided by 2x. Now I'm going to go over to this side and we're going to be starting our substitutions. First step is I'm going to take, so x squared minus 1 right here, this is going to become u. That's all I did in this step. I just simply substituted this u right here because the u is right there and these two are equivalent. Next thing is this dx right here, I'm going to be substituting du over 2x. Go ahead and do that. Alright, after I substitute the dx, what I'm going to do is cancel out things that cancel if possible. Here, this x is on top, this x is in the bottom. So I'm going to cancel this x and this x. So what we have now is this. Alright, we're almost done here in our U-substitution. This du over 2, I'm going to rewrite that. Instead, I'm going to, because this over 2 is actually equivalent to 1/2, I'm going to rewrite that 1/2 and move it in front. These two expressions right here are equivalent. Now, what we have is the integral of 1/2 u to the third power with respect to u. That is what this expression is saying. Basically, now that we're up to here, we could go ahead and now use the power rule. Remember, the power rule is x to the n plus 1 divided by n plus 1. So basically, this 1/2 is going to stay in front. This right here is going to become u to the 4th divided by 4. Then I'll put plus c. because we have indefinite integration right here. So see, I just used the power rule here, and this is just with respect to u. Okay, 2 times 4 is going to give me 8. We are almost done with my u substitution. Now the last step is because my original problem was asking to take the derivative with respect to x, my last step now is this u right here, because it's not in terms of x, I have to go back now and plug in what my u was. My u was equal to x squared minus 1, so this is going to go right here. And I went ahead and plugged that in, and you guys can see this in blue now. Now I am done. So as you can see, u substitution helps us find integrals of functions that are hard to do. We could not use power rule in this example, right? But once I used u substitution, I was able to go ahead and use power rule to solve for this. Let's move on to example 2. Alright, example 2. Let's go ahead and try to remember the steps here. So the steps is first, identify the inner function. We're going to call that u. The next step after doing that will be to solve for dx. These will be the steps when we're doing u substitution. As you can see right here, we cannot use power rule. We can't use power rule because this is not in the format of a power by itself, because there's an inner function. Think of this like a chain rule with integrals. So again, here's my color codings. I always color code the inner function as blue, and I always color code the dx as red, because those are the two things that we'll be substituting. Alright, so again, my first step, the inner function we're going to call u. The next step is we're going to take the derivative of both sides with respect to x. This side right here will become du dx. This side over here, since it's their derivative with respect to x, this just will become 2, because the minus 5 is a constant, that just becomes 0. There's our equation. Now remember, the next step in this process is to solve for dx. Because dx is in the bottom, we have to multiply both sides by dx in order to solve for dx. This right here will cancel. Then you're left over with du is equal to 2 dx. Again, dx is not by itself fully, so what we're going to do is divide both sides by 2. Now my dx is solved for. Great. So now I have my u, I have my dx. I am ready to now go back to my original and substitute. So this right here in blue, that was u. So this is going to become u in this next step. Alright, now let's go ahead and substitute the dx that we just found. My dx is equal to du over 2. Alright, again, this division by 2, this basically means 1/2. And then the du is just going to come out. Great. As you can see now, what I have is an integral of 1/2 u to the 5th power with respect to u. So I could go ahead and use my power rule now. So this 1/2 is going to stay out in the front. This right here will become u to the 6th divided by 6 plus c. Great. 2 times 6 is going to give me 12. Well, I guess I didn't do the 2 times 6 yet, right? So actually what I did in this step, I went ahead and I plugged in already my u, actually, and I did not color code that, but you would see this as blue. Then I went ahead and will multiply the 2 and the 6. You could have multiplied 2 and the 6 first. And then basically now you are done. This right here is the integral. Alright, let's move on to number 3. Here's my color codings. Again, I identify, by the way, my first step will be to identify what is the inner function in this expression. The inner function is usually the one in parentheses, which is right here, the 4x minus 1. I'm going to color code that as blue. My dx is always red, so that's the explanation of these color codings. Alright, first step, identify u. That's right here. Next step, take the derivative of both sides. Alright, the left becomes du dx. On the right, we just have 4. In order to solve for dx, we're going to multiply both sides by dx. On the left right here, the dx is canceled, so we have du is equal to 4 dx. In order to solve for dx, we're going to divide both sides by 4. Now we have dx solved for. My next step, after I have my u and I have my dx solved for, I'm going to go back to this expression and substitute. This thing in blue right here will become u. This dx right here, that's going to become du over 4. Alright, so because this is divided by 4, this is basically like saying 1/4. So, because I have a 3 right here, this whole expression is going to become 3 over 4 right here in front. And then we have du. Awesome. So as you can see, now that we have it in this format, we can go ahead and use power rule. So it's going to be, for this portion, it's going to be u to the 2/3 plus 1 divided by 2/3 plus 1. So 2/3 plus 1, that's the same thing as saying 2/3 plus 3 over 3, which is basically 5 over 3. And then this 3/4 right here, because it's a constant, it's just going to stay in front. So that's my next step that I did right here. I took the integral. Alright, now what I'm going to do is basically simplify any fractions. My pre-calculus rule, when you're dividing by a fraction, you got to remember to flip and multiply. So this 5/3, I'm going to flip it and then multiply. 3 times 3 is 9, 4 times 5 is 20. Awesome. Now our last step is to go ahead and plug in our u, which was 4x minus 1. So this u right here is going to become parentheses 4x minus 1, and you are done. This is the integral for this function. And remember, we always plug in the x back into the u right here because the question is asking with respect to x. The u substitution basically helps us find the integral, but we can't keep our answer in the u format. This last problem involves a little more steps. Okay, so in this case, identifying the inner function might be a little more difficult because there isn't something in parentheses. But there is something inside. There is a function inside of something else. I noticed that there's a fourth root here, and we have a 5x squared plus 2. This right here is actually going to be my inner function. So this right here is going to be the u. And then the dx I'm going to color code as red. Alright, let's go ahead and set it up. So u is going to be equal to 5x squared plus 2. The next step will be to take the derivative of both sides with respect to x. On the left, we're going to have du dx. On the right, we're going to have 10x. To solve for dx, the process is the same. Multiply both sides by dx. On the left, the dx is cancelled. On the right, you have 10x dx. To solve for dx, you're going to divide both sides by 10x. Great. So now that you have u solved for and you have your dx, we're going to go now back to our original equation and we're going to make our substitutions. This blue part right here will become u. This dx right here will become du over 10x. Let's go ahead and substitute. My first thing was the u. The next step, I'm going to put in that dx in red. Great. Now, before I do any other work, you want to simplify first. So 2 and 10 right here, I know that a 2 cancels and a 2 cancels here, and you're left over with a 5 down here. It's a good thing that these x's fully cancel, so these x's disappear. So basically what you're left over with is du over 5 after you do those cancellations. Alright, what I'm going to do next is this over 5 basically is like saying 1/5 in front. Alright, great. So now that it's in this format, I mean, we're almost ready to use the power rule, but we got to take care of this radical right here, this root, this fourth root. Remember, we got to first convert this to an exponent. So this fourth root right here is going to become u to the 1/4. Now, again, we still have a problem because this u is in the denominator position. In order to use the power rule in integrals, you got to make sure you move this u back up into the numerator position. You can do that by making its exponent negative. And that's what we did in this step. We moved the u up by making the exponent negative. Now that we have it in this format, we can go ahead and take the integral. We're going to be using x to the n plus 1 divided by n plus 1. Of course, instead of x, we have u right now. Alright, so negative, basically the 1/5 is going to be in front again because it's a constant. Now, negative 1/4 plus 1, that's the same thing as saying negative 1/4 plus 4 over 4. That is equal to 3 over 4. And of course, we'll be also dividing by 3 over 4. This right here is the power rule of integrals. Alright, now our pre-calculus rule, when you divide by a fraction, you have to make sure you flip and multiply, which is going to be my next step. 1 times 4 is 4, 5 times 3 is 15. Awesome, so now we're basically done with simplifying. But again, because the question is saying what is the integral of this function with respect to x, we have to make sure that our answer is in respect to x, basically in terms of x. So our last step is this u right here. You're going to substitute what you said u was at the beginning, which is 5x squared plus 2. We're going to keep that in parentheses, and we are now done. This is the antiderivative, this is the integral. And this right here, 3/4, this is a power, this is an exponent. It just looks a little large here in the PowerPoint. So now what I want you to do is to go ahead and do the problems on the right side of your sheet.